All right, so for the second part of conics is what we're going to do is we're going to go backwards from what we've been doing. So far, what we've done is we're given a conic that's in quadratic form, and our job was to take that conic and make a graph of it. Now, what we're going to do is we're going to go backwards. We're going to go from a graph of a conic, and we're going to go all the way back to the quadratic form of the equation. Now, before we do that, though, before we start with the note sheet, there's a couple corrections I have to make. The first correction is we need to change horizontal and vertical. The reason being is because what we're going to do today is we're going to learn how to write equations for parabolas and for ellipses. Now, the reason I have to change that is in a parabola, if x is being squared, we actually have a vertical parabola, and if y is being squared, we actually have a horizontal parabola. So this was a mistake that needs to be corrected before we get started. All right. Now, in order to write the equation of a parabola, there's three things that you need. You're going to need your h, you're going to need your k, and you're going to need your p-value. Now, just as a quick refresher, remember, for every parabola has a vertex. Your vertex is h, comma k. Every parabola also has a focus, and your focus is always p units away from the vertex. So wherever your vertex is, your focus is going to be p units away. Now, of course, if your focus is p units away, your directrix is also p units away. So let's say here is my directrix. All right, so p is the distance from your vertex to your focus, or the distance from your vertex to your directrix. These three things are going to be what we're going to need to write our equation. So let's look at an example. Example number 1 says that we're given this parabola. Notice where the vertex is, notice where the focus is. First thing we need to do is, in order to write an equation, again, for a parabola, you need three things. You need to figure out what your h, your k, and your p is. Your h and your k is always going to be based on your vertex. So figure out where your vertex is. In this case, here's my vertex, and I need the coordinates of the vertex. The coordinates from my vertex, based on my coordinate plane, it looks like 1, 2, 3. So 3 to the right, 2 down. So it looks like my vertex is 3, negative 2. What that means is if my vertex is 3, negative 2, here's my h value, there's my k value. So we know what h is, we know what k is. So we're saying h is 3, k is negative 2. Now the third thing we need to write an equation for a parabola is your p-value. Your p-value is the distance from your vertex to your focus. So here's my vertex, here's my focus. Based on this coordinate plane, it looks like it has a distance of 1 unit. So that means my p-value is 1. Now, once we have h, k, and p, what we're going to need to do is we're going to need to write this equation in standard form. And there's two versions of a parabola's equation. You're going to need to choose the correct version. This parabola is open vertically. So what that means is I need to use my vertical form of my standard equation. So I'm going to start with my standard equation. X minus h quantity squared equals 4p y minus k. Now what I'm going to do is I'm going to take each of these values and plug it in. However, you want to be careful of a couple of things. First of all, remember your h always is opposite. So if our h was a positive 3 for our vertex, it means inside of our equation it's going to be a negative 3. 4 times p is the coefficient out here, so 4 times 1, because that's what our p-value is 4. And then y, if k is a negative 2, we're going to need to put a positive 2 in my equation. Remember, h is always with x, k is always with y. Now, here's our equation in standard form. This is pretty good so far, but it's not good enough for what we need to do. What we need to do is we need to take this equation and write it in standard form, which means that all the variables are on one side, zeros on the other side. So, a couple of things we can do. First of all, this x minus 3 squared, we could take this binomial here and we could square it out. So, using our square pattern, first term squared, multiply and double, so it's going to be negative 3x, square the last term. So there's the x minus 3. I'm sorry, this should be a 6. So there is our x minus 3, quantity squared. Now my right hand side, I could distribute that 4. So we'll have 4y plus 8. Now once we have this form, all I'm going to do is I'm going to take everything to the left hand side. That way we have a 0 on the right hand side. So I'm going to subtract 4y and I'm going to subtract 8. Now as far as the ordering goes, we usually try to put x's first and then put y's next. So all I'm going to do is I'm going to arrange my x's first and then my y's next. So we're going to have, once I rearrange everything, x squared minus 6x minus 4y. The only terms I can actually combine is that 9 and the 8. So 9 minus 8 gives me a positive 1. Right hand side, everything cancels, so we're left with 0. So here is our parabola in quadratic form. All right. Now example number 2. Example number 2 is a little bit different because we're not given a graph. We're only given certain points. Now it is going to be to your benefit to sketch a quick graph of the parabola. Nothing fancy, but just sketch it. That way you get an idea of what it looks like. So what I'm going to do is I'm just going to roughly sketch this parabola. Now we know the vertex is at negative 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. So here's my vertex here. My focus is 0, 5. So we're right at the origin. We're just going to go up 5. So there's my focus. Now, to get an idea of what the parabola looks like, remember your focus is always inside of your parabola. So what that means is my parabola actually opens from my vertex outwards. So something like that. Now, the reason we want to know what orientation it is because that way we could decide whether we're going to use a vertical or a horizontal form of the equation. Now, because my vertex is at negative 3, 5, and my focus is at 0, 5, this makes it a horizontal parabola. So what I'm going to do is I'm going to use my horizontal standard form. So y minus k quantity squared equals 4p x minus h. Same thing. Let's get our k value. Let's get our h value. Let's get our p value. So h, k, p. Now remember, h is the x value of the vertex, which is negative 3 here. K is the y value of the vertex, which is 5. P is the distance from the vertex to the focus. So here's my vertex. Here's my focus. Because I went right to get to my focus, it is going to be a positive 1, 2, 3. So my p-value is positive 3. If my focus was the other direction, it would be a negative 3. So make sure you guys are very careful with your p-value. From there, let's plug in. And keep in mind, h is always with the x value, k is always with the y value. So when I plug it in, I'm going to use the 5 for my k, but make sure it's opposite. So if I have a k of positive 5, my equation is going to be a k of negative 5. So y minus 5 quantity squared equals 4 times p, in this case 4 times 3 is 12, x, my h is negative 3, but in my equation he's going to be a positive 3. So there's my standard form, but again, that's not good enough. We want to take it a little bit further. Let's take this binomial and square it. This binomial, when you square it, is going to be y squared minus 10y plus 25. Let's distribute that constant to make it 12x plus 36. And finally, let's move everything over to the left-hand side, combining whatever like terms we can. So minus 12x, minus 12x, minus 36, minus 36. Right-hand side is all going to be zeros, just like we want. Left-hand side, again, let's arrange it so that the y's come first. I'm sorry, let's arrange it so that the x's come first. So we have negative 12x, so he's out of there, plus y squared minus 10y. We can combine the 25 and the 36. We could call that negative 11. And here is our equation in quadratic form.